First thing, tell me, do you guys have any doubt for what we have read until now?
Yes.
No, sir.
Okay, fine. So, do you guys read, like revise all these stuff which I'm teaching in class or not? Because if you don't have any doubt, there may be two conclusions. Either I'm teaching very good, which I don't think is true, or either guys don't read it or revise it what is taught in the class. Which one is true? Yes. Okay. Okay. Fine. We have seen up to what the testers and let me open the book only. Wait a second.
Sir,
Yes.
sir, in light to find the angle between the incident ray and reflected ray, what's the formula to find it?
Incident ray and reflected ray. You have to find first the angle of incidence and then the angle of reflection using
Sir,
the
the
laws
teacher
of
told us
reflection.
that the statement should be since angle I is equal to R, we can add both of them.
Yes, we can add both of them. Correct.
So, sir, will the statement be since angle of incident and reflected ray are equal, we can add them?
What are you saying?
Sir, like the statement for solving,
Mhm.
can I write since the incident ray and reflected ray are equal, we can add both of them?
Yes, we can add. See, if it is given that you need to find the angle of incidence. Okay, what it is given in the question. Let's take this
So
angle
it is
is
40 degrees, 40 and 25 degrees. One is 40,
what
the other one is 25.
40 and 25. It won't be possible
No, sir,
if you take.
one is 40 and the other diagram has 25.
Okay, so let's say this is 40 degree and
Yes,
you
sir.
need to find the angle of incidence and the angle of reflection. Okay, so
Yes, sir.
you know that according to the laws of reflection, the angle of incidence is always equal to angle of reflection, correct?
Yes, sir.
So you will make a normal to this surface, the mirror, and so this angle I, let me change this color. So this angle I is equal to this angle R, and we know I plus R is given as 40 degree, correct? Is this correct what I am
Yes,
writing?
sir. Yes, sir.
And according to the first law of reflection, we know I equal to R, so we can write I plus I equal to 40 degree. So 2I equal to 40 degree and I will be
20.
20 degree. So if I is 20, then R will also be
20. Yes,
20.
sir.
If your other question is 25 degree, if this angle is 25 degree, in that case I will become 12.5 degree and R will become 12.5 degree. Okay,
Yes, sir.
the half of this angle.
So 20 degrees is the angle between between angle I and R, right?
No.
What are you saying?
Sir,
Repeat it.
will 20
Yes,
degrees be the angle between I and R?
No,
20 degrees.
so it's
Mhm.
the angle between the incident ray and the normal and reflected ray.
Not normal and reflected ray. The angle which you are saying is 20 degree. It is between the incident ray. This is incident ray. Incident ray. This is the normal. Okay. The perpendicular line. The
Okay.
angle between incident ray and normal is 20 degree.
Yes, sir.
Don't you remember the definition of this angle of incidence? So the angle of incidence, it is the measure of the angle between the incident ray and the normal to the
Yes.
surface. And similar is the case for reflected angle of reflection. It is the angle between the reflected ray and the normal to the surface. Okay. Any more doubts?
Sir, there's one question in the worksheet.
Mhm.
Sir, it's a series of fast-moving still pictures can create an illusion of movement. Why?
Mhm.
What is this phenomenon called? Sir, it's called effect in
What
the
is
eye, right, sir?
what is the question? Repeat again.
Sir, I'll send it in chat.
Okay. Okay. Until then, let's move ahead. So we were discussing this activity, activity 11.6. So in this activity, we take two carbon rods carefully from the discarded cells, clean their metal caps with sandpaper. Can anyone explain me what is sandpaper?
So it
Yes.
is used to smoothen a surface.
It is used to smoothen a surface and
Okay, very good. So it is used to smoothen a surface and remove the impurities. Okay, so it is used to remove the impurities and smoothen the surface. So it is a carbon paper, uh, sandpaper, sorry. Clean their metal caps with sandpaper, wrap copper wires around the metal caps of the carbon rod and join them with the battery. So why have we wrapped them with the copper wire?
So because they are
So
good
that they don't
conductors.
conduct electricity.
So they are good conductors.
Good conductors, very good.
Sir, while copper is a bad conductor, so it will.
No, copper is not a bad conductor. Copper is a good conductor. That's why we use copper in the wires. In electrical wires also, we use copper.
Yes, sir, I got confused.
Okay, can you tell me why we use the outer layering as plastic in the wires?
sir, so that we don't get electric shock. Plastic is a bad conductor of electricity.
Perfect, perfect. Good answer, Dhriti. So we call these two rods as electrodes. So we were discussing about these two rods, the carbon rods. So these two rods are known as electrodes. Okay.
So what is the exact definition of electrodes?
So electrode is hmm, okay. You can say that electrodes are those metal rods which are used for chemical reaction. Okay, chemical reaction in a liquid. Metal rods used for chemical reaction. Okay.
Yes.
So carbon rods, you may take two iron nails. Okay, okay. So it is saying instead of carbon rods, you may take two iron nails about 6 centimeter long. So iron is also a good conductor of electricity. That's why instead of carbon, they are asking to take iron rod, two iron nails. Sorry. Pour pour a cup full of water in a glass plastic bowl. Add a teaspoon of salt or a few drops of lemon juice to what to make it more conducting. Now immerse the electrodes in this solution. Make sure that the metal caps of the carbon rods are outside the water. Wait for 3-4 minutes. Observe the electrodes carefully. Do you notice any gas bubbles near the electrode? So in this experiment, when this carbon rod is dipped and we have used a battery. So this is battery. This battery is supplying electrical current. So when this electric current is passed through this solution, some bubbles are forming out, and this bubble is indicate that there are some kind of chemical reaction taking place inside this solution. Okay, when you do this experiment, you will observe bubbles coming out. So if the bubbles coming out, that tells us that there is a chemical reaction due to electric current. But if there are no bubbles, you will understand that there is no chemical reaction taking place. Can we call the change taking place in the solution a chemical change? Yes, obviously. I have told you that there are some kind of uh, what we say. mm, Okay, there are some kind of changes according to which we can conclude if it is a chemical reaction or not. Those are either fumes coming out, fumes, the smoke we say. Okay, fumes, small, the air coming out, fumes, bubbles, or what else? Color change. Okay, pencil is working very bad. Let me put it another definition. Chemical effects. Okay, here we were discussing about this reaction. So how you can uh, how you will know that if there is a chemical reaction or not. So if there is a chemical reaction, there would be either fumes coming out, there would be either bubbles coming out, or there would be either change in color of solution. Okay, the material in which we are applying electric current, if that material is changing color, that means the chemical reaction is taking place. Recall the definition of chemical change that you have learned in class 7th. Can you anyone of you tell me what
So,
definition you have
chemical
learned?
change is a change in which new substances are formed.
Okay, very good. So
And
chemical, yes, so chemical changes are those change in which new substances are formed. New substances are formed, and this new substance, the formation of the new substance can be identified with the help of fumes, bubbles, or change in color. Whenever there are these three things happening, that means new substances are formed. Fine. So in 1800, a British chemist, William Nicholson, had shown that if electrodes were immersed in water and a current was passed bubbles of oxygen and hydrogen were produced. Oxygen bubbles formed on the electrode connected to the positive terminal of the battery, and hydrogen bubbles formed on the other electrode. The passage of the passage bit. Okay. The passage of electric current through a conducting solution causes a chemical reaction. As a result, bubbles of a gas may be formed on the electrodes. Deposits of metal may be seen on the electrodes. Change of color. Okay, so this is also the effect of the chemical effect of electric current. See, this experiment will come. Okay, that experiment is this one. You will get to know that how this thing is happening. Okay, this is important application of electric current. That if we use two metals, if you use two electrodes, one electrode may degrade, it may become small. Okay, that one electrode may degrade and it may become thin, while all that material which is degraded from that electrode may deposit on the other electrode. So this is application of deposition. Deposits of metal may be seen on the electrodes, whereas changes of color of the solution may occur. Okay, as I have told you that if there is change of color, there is chemical reaction taking place. The reaction would depend on what solution and electrodes are used. These are some of the chemical effects of the electric current. Let's say we took one more example to know if if there is a chemical change or not. We have taken one potato. We have taken one potato and we applied two terminals of our tester in the potato. This is the battery, as you all know, and this is our indicator. Can you tell me what kind of indicator we are using?
Magnetic.
Yes, magnets. So we are using magnetic compass. And how we have formed this magnetic compass? We have taken one empty matchstick, matchbox. One empty matchbox. We have put a magnetic needle in that, and we have wrapped it with the help of which wire? Can you tell me?
Copper.
Copper. Copper, very good. We have wrapped it with the help of copper wire because copper is a good conductor of electricity. Fine. So we then inserted one terminal of this tester here and the other terminal here. And when we applied, okay, can you tell me why we are using magnet and not an LED or a other bulb?
So with a small current also it gets deflected.
Very good, very good. So we are that is the reason because of which we are using magnetic needle here. So when we applied the electric current, we observed that there is a change in color of one spot in the potato. Okay, and if there is a change in color, can you tell me what kind of effect we are observing?
An electric.
Change in color of the solution.
Yes, change in color. And what kind of effect is there is of electric current?
Chemical effect.
Chemical change. Chemical
Chemical
change.
effect.
So,
Chemical.
but why does that not happen on the other terminal?
So basically, see, when the positive terminal is the current is coming out of positive terminal. Do you agree with it?
Yes, sir.
So when the current come out of positive terminal and it enters at this point, so basically the current is entering from here. Okay, it does not matter it is reaching to the other end or not, but it is coming and it is going through this point. So all those effect will take place at this point. And also there is this is like, according to me, this may be happening, but there is no clear reason why it got colored at this point and not the other point. Okay,
So
according to
is
me.
potato a conductor?
Is potato a conductor? What do you What do you think? Is it a conductor or not?
No, sir.
No. So, okay, we will go through it and then we will know if it is a conductor or not. Let me read it. So, Bojo decided to test whether some fruits and vegetables also conduct electricity or not. He cut a potato into two halves and inserted the copper wire of a tester into it. Just then, his mother called him and he forgot to take out the wires of the tester inserted into the potato. When he came back after half an hour, he noticed that there was a greenish blue spot on the potato around one wire, whereas there was no sign spot around the other wire, like you asked. He was surprised with this observation along with Paheli, repeated this activity many times. They found that it was always the wire connected to the positive terminal which had a greenish blue spot around it. They felt that this discovery was very useful because it could be used for identifying the positive terminal of a cell or a battery concealed in a box. They decided to report this finding to the children's magazine. Remember that Bojo set out to test whether the potato conducted electricity or not. What he found was that the current produced a chemical effect in the potato. To him, this was very exciting. In fact, this is how science sometimes work. You are looking for something and you discover something else. Many important discoveries may have made in this manner. So basically, if see, if there are some kind of vegetable which have ions, okay, the ions like salt, as I told you, the salts which is responsible for the water to make it a conducting material. So if any vegetable contain some say salts or
Sir,
ions, yes.
sir, if a vegetable is bitter and it has the
Mhm.
basic properties, will the current flow that time?
If it is a bitter and it is a basic okay, okay, it depends on that material only if it is allowing electric current to pass through it or not. uh, like with only this detail that it is basic in nature, we will not be sure. Let's say if you are taking a liquid of the same kind, if you have tasted a liquid which is a bitter, that means it is a base, so you can directly conclude that it will conduct electricity, but that may not be true in case of a fruit, because fruit is a solid thing, and for that, if a current is passing through a solid, it must allow, or it must have free ions to like travel from one point to another. Okay, we can search for some kind of vegetables which allow electric current and which may not. Okay, let's do it.
Okay.
Mhm. Yes, potato is conducting. Fruit vegetable voltage conducted. Lemon 0.99, potato 0.98, apple 0.78, cucumber 0.75, tomato 0.87, avocado 0.989. Mm. So according to these experiments, the lemon conducts the most electricity when compared to other fruits and vegetables. So here, according to the experiments, potato conduct. Okay, so it conduct electricity. Why we are measuring it in the terms of voltage? Can anyone tell?
To understand how much it conducts.
To understand how much it conduct. Very good. Okay, and we can search for other vegetables also that does not conduct. Poor conductors of electricity. So there are some vegetables which are poor conductor of electricity, like onion, cabbage, cauliflower. These are poor conductors of electricity. If you do this experiment on these vegetables, then you won't get any kind of electric current. Okay, any doubt?
No, sir.
Okay, so these so you won't be able to know a conduction of a vegetable by knowing its nature only. Okay, like the here experiments are done. Okay. Mm, let me show that. Okay, so these science experiments have told the scientists that lemon conduct, potato conduct, apple conduct, cucumber conduct, tomato conduct, avocado conduct. So without experiment, you cannot know if a vegetable will conduct or not. Okay, it is the liquid solutions which we can directly tell. Let's say if a liquid solution is acidic, we can directly tell that it will conduct. There is no doubt about it. But for vegetables, these are solid materials. We need to do experiments, and then only we can confirm whether it will conduct or not. Fine. So next we are moving to electroplating. So you know that a brand new bicycle has shiny handlebar and wheel rims. However, if these are accidentally scratched, the shiny coating comes off, revealing a not so shiny surface beneath. You might have also seen women using ornaments which appear to be made of gold. However, with repeated use, the gold coating wears off, revealing silver or some other metal beneath. In both these cases, a metal has a coating of another metal. Do you wonder how a layer of one metal can be deposited on the top of another? Well, let us try doing it ourselves. So now we will understand a particular kind of experiment which which perform this activity. Okay, as I have told you, the deposition of one metal on another. So this is very important in the chemistry. We call this kind of phenomena as electroplating. When one metal is deposited on another metal, and this kind of uh, this activity is very important. Why? Because let's say there are some material. Mm, okay, you know about iron. You must have seen the rusting of iron, isn't it?
Yes.
Yes.
So rusting of iron is a very common phenomenon we all observe in our surrounding. Okay, when the iron is left in the surrounding, can you tell me the reason behind this rusting?
Because of moisture in the air, it gets rusted.
Perfect. Because of the moisture. Okay, the moisture which is present in the air, due to which the moisture plus the wind, the air which is present. So due to these two, the rusting of iron happen. Okay, so the rusting of iron, what this rusting of iron do? It degrade the quality of iron. So we use specific kind of materials. We deposit specific kind of material on this iron so that the rusting does not take place. Okay, so there are some kind of material. Let's say this is iron bar. Earlier, when the moisture was coming on this when the moisture was coming in contact of this surface, this was getting rusted. It was getting brownish. Okay, it was getting rusted. But let's say now I am doing electroplating. What is electroplating? That I will deposit another metal on this metal. So after electroplating, let's say we have deposited aluminum, a layer of aluminum on the surface of this iron. Now the moisture which is coming to the surface will not form rusting. Why? Because it was the reaction. Okay, earlier it was iron, Fe. We represent iron as Fe plus the H2O liquid. or we say aqueous. Forms a Fe2O2, I think, or O3, something like that. Don't go with the particular. Can you tell me why I have taken H2O here in this chemical reaction?
Sir, because you have to do it with a liquid.
So
Yes,
because
as
it represents moisture.
moisture,
Air.
perfect. So the moisture which is present in the air, it is water only, but in the form of gas. Okay, in the form of aqueous. Aqueous, we say the neither gas, neither liquid. So it is in the middle state. Okay, so the moisture which is present, the humidity, we say that there is a humidity in the air. That means there are water vapor which are present in the air. So this water vapor is H2O. The water vapor are generated from water only. Okay, when the sunlight is incident on a water, it gets evaporated and it goes in the air and it stays there. Okay, so when iron is reacted with this water vapor, it forms a specific kind of chemical change. Are you do you agree with me that this is a chemical change? No? Can you tell me what is chemical change?
So when new substances are formed.
New substance is a form. Very good. So earlier it was iron only, but now it is iron plus some oxygen. So isn't it a new substance?
Yes, sir.
Yes. So earlier it was iron only iron. But now the oxygen has combined with this iron and it has formed some new kind of material, which is we know call as rusting. And this new material is brownish in color. Okay, so it is the property of iron that when it is reacted with the atmosphere, which is sorry, when it is reacted with the vapor, or we say moisture, when it is reacted with moisture, it goes undergoes chemical change. When it goes a chemical change, it form new kind of substance which is brownish in color, and we say that the iron has been rusted. But now I have deposited aluminium layer, but now I have deposited aluminium layer on the top of this iron. Now can you tell whether it will get rusted or not?
No, sir.
No, because the aluminium does not react with the water vapor, or we say moisture. So this aluminium does not get reacted with moisture, due to which it won't go a chemical change, and the surface won't get rusted. So this is the importance of the electroplating. With the help of electroplating, we can we can save material from getting spoiled, or we can save material from getting degraded, because rusting itself degrade the quality of iron. So that's why we do aluminum plating, due to which the material does not get degraded. There are some ornaments also, mm, like there are jewelry. In jewelry there is gold. Okay, so the gold also react with the moisture, not moisture but actually the liquid water. So the gold reacts with the liquid water. That's why there are some kind of gold plus copper and silver plating, which is done on the surface, the electroplating, due to which the gold does not undergo chemical change. So there are many materials we uh, uh, in your homes. Have you observed that before coloring your walls of the home, we apply
Yes, sir.
plastering? Yes. So there is the wall contains CaO. quick lime. Okay, don't go. Let's not go inside. But the wall, the earlier when we there there is normal wall. We have done the like cementing on the wall, and then we apply plaster. But if we do not apply plaster, that cement gets go undergoes a chemical reaction on the carbon dioxide. Okay, as you know, the CO2 is present in the air, and if there is a wall, the cemented wall, this cemented wall reacts with this carbon dioxide which is present in the air, and it goes undergoes chemical reaction. So there are some whitish color change in the walls. Okay, when it is reacted with carbon dioxide and it is reacted with water, H2O. Like if there is raining, the cement undergoes this chemical change, and the color of the wall changes. So that's why before coloring these wall, we apply plaster. Okay, what this plaster do? Plaster will stop this wall from getting reacted with the CO2. When we plaster this, this wall, it stops it from getting reacted with CO2, and then we apply different kind of colors, so that if there is raining also, then also the color of the wall or the wall does not react with that water and carbon dioxide which is present in the air. So there are many application, daily application. The wood, the furniture you are using, the chair you are using, the table you are using, there is specific kind of coating which helps the material from not getting degraded. So these are all application of electroplating. Okay, understood? So now we are doing this experiment. Here we will need a copper sulfate, and we will need copper sulfate and two copper plates of size around 10 centimeter into 4 centimeter, and take 250 ml of distilled water in a clean and dry beaker. Okay, we have taken a beaker and we have taken distilled water in it. Dissolve 2 teaspoonfuls of copper sulfate in it. Add a few drops of dilute sulfuric acid to copper sulfate solution to make it more conducting. So the in the end, the only, like, the basic thing which we are going through a solution is that the solution should be conducting. If the solution is conducting, then only the current will pass through it. If the solution is not conducting, then the current will not pass through it, and there won't no kind of reaction will take place. So we have made this solution conducting by first applying the dilute sulfuric acid to copper sulfate solution. Okay, to make it more conducting. Clean copper plates with the sandpaper. Again, we are using sandpaper to make the surface smooth and remove all kind of impurities which are present on the surface. Now, Ryzen, uh, now rinse them with, okay, actually it is making it wet with water and dry them. Okay. Uh, what is the meaning of rinse? Okay, let me see. Okay, wash. Clean water to remove some. Okay, so that's what I was explaining, that first it will wash with the, we will wash these plates with the water, and then we have dried it. Then connect the copper plates to the terminals of the battery and immerse them in copper sulfate solution. Okay, so this is copper sulfate solution. The blue color solution is copper sulfate solution, and we have
Sir, I
dropped.
have a doubt.
Yes, ask.
So will the solution always have positive ions only?
Not necessary. It will have positive ions. Like, it will be a mixture of positive and negative.
So because the material that is to be coated is kept at the negative terminal so that the solution is attracted over there. So it should be positive all the time.
Mm, not okay. It depends on the type of solution we are using. The copper sulfate is known as Cu SO4. Okay,
It's
if
positive, right?
it is both, when CuSO4 is split, it is Cu plus 2, SO4 minus 2. So it contains both Cu also, SO4 also. But it depends on the type of material which is depositing. Okay,
It's
wait for 5 minutes and you will understand that. Okay.
okay.
Okay. Before this, I was explaining you one thing. Okay, it will come to me. Fine. So this blue color solution is copper sulfate solution, and these are copper plates which are attached to two terminals, terminal 1 and terminal 2. Okay. Now allow the current to pass for about 15 minutes. Now remove the electrodes from the solution and look at them carefully. Do you find any difference in any one of them? Do you find a coating over it? What color is the coating? Note down the terminal of the battery with which this electrode is connected. So after doing the electroplating activity, Bailey interchanged the electrodes and repeated the activity. What do you think she would observe this time? So when the electric current is passed through the copper sulfate solution, the copper sulfate dissociate into copper and sulfate. As I have told you, CuSO4 is copper sulfate, and it is dissociate into Cu plus 2, SO4 minus 2. The free copper gets drawn to the electrode connected to, can you tell me, which terminal?
So
Negative
negative.
terminal, cathode.
Yes, negative. Okay, so it is attracted towards the negative terminal of the battery and
The
gets
sulfate
deposited
will
on.
be attracted to the positive one.
Yes, sulfate will be attracted to the positive. So it is saying that it is the gets drawn to the electrode connected to the negative terminal of the battery and gets deposited on it. Okay, so underline this one, that it gets deposited on it. Okay, but what about the loss of copper from the solution? From the other electrode, a copper plate. Okay, it is asking what about the loss of copper from the solution? Can you tell me?
So from the other copper plate, the copper gets deposited in the solution so that it gets attracted towards the negative terminal again.
Perfect. Okay, so we are using two copper plates, and the solution is also copper sulfate solution. So basically, if let's say we were using sulfate plates, okay, the SO4 plates. Let me say, if we were using SO4 plates, sulfate plates. Can you tell me what would happen at that time?
So what is sulfate? Like sulfate plates. Like copper is a
So
metal. What is sulfate?
sulfate is a like compound of sulfur and oxygen. So I am randomly taking sulfate. Okay,
Okay.
just to understand that how this phenomena is happening. Earlier we were having copper plates on both sides, and we were using copper sulfate solution. So what would happen, that the copper sulfate solution will break down, the copper will go to the negative plate, the negative terminal, and it will deposit it on it. Okay, so this one is negative, this was negative, this one is positive. So it gets deposited on the negative plate, whereas the positive plate will break down into solution. The copper from positive terminal will break down, and it will dissolve in the solution, and then it also gets deposited. So basically this plate is getting broken down into small, and this plate is getting bigger. Okay, so this plate is getting bigger. So this is what happening. Okay, but now let's say I'm taking a random, a hypothetical plate, sulfate plate. Sulfate plate is not actually used, but I'm taking a sulfate plate. Let's say I'm taking a sulfate plate, SO4 plate. What would happen now?
So
Can you imagine?
So the material which is to be coated would be attracted towards the positive side.
Perfect. So this will break down into Cu plus 2, SO4 minus 2. The SO4 minus 2 will be deposited on the positive terminal. The positive terminal, okay, it will get deposited from the positive terminal. The SO4 which is present on the negative terminal will break down. It will break down. It will become small, and this will get deposited on the positive terminal.
So do we
So
add sulfate to the solution, or we just keep the water and wait till the sulfate is dissolved from the plate?
yes, we will wait for the sulfate from the plates to dissolve in the solution, because the sulfate which is present inside the solution is limited. There would come a time in at which this sulfate will get exhausted, so the all of the sulfate will come from this plate and it gets dissolved in the liquid. So basically now you can understand that the final crux of this electroplating is that if you want to deposit a material on a plate, you need to have the same kind of plate on the other terminal. Okay, got it? What I'm explaining, that if you want to deposit copper on the negative plate, if you want to deposit copper to the negative plate, you need to have copper plate in the positive terminal also, so that the positive terminal plate will break down, it will become small, and it gets deposited on the negative terminal plate.
So is it compulsory that the material on the negative terminal is made of copper, or we can keep anything?
Yes, we can keep other materials also, because the basically what we are doing, we are trying to deposit the metal on the plate which is present in the negative terminal. Okay,
Okay.
so we can take other plate also on the negative terminal. Let's say you want to deposit, instead of copper, you want to deposit aluminum. So you will take aluminum plate on the positive terminal. See this all, and you will take as aluminum sulfate or some aluminum solution. Okay, not copper sulfate solution, but some aluminum solution, so that this aluminum will get deposited on this plate, and after that this plate will also breaks down into small, and it's get deposited on the negative terminal plate. So we will take same kind of solution which we want to deposit, and the same kind of plate which we want to deposit on the negative terminal plate. From the other electrode, a copper plate, an equal amount of copper gets dissolved in the solution first. The loss of the copper from the solution is restored and the process continues. Okay, got it? That there was earlier a loss of the copper in the solution, which was compensated by the copper which was present on the plate. So the loss of the copper from the solution is restored and the process continues. This means that the copper gets transferred from one electrode to the other. This is
No.
electroplating. Yes.
So both the copper plates should lose the same amount of copper, right?
Not necessarily. Okay,
So
let me.
why does only one plate lose and the
Okay,
other gains?
okay, you can understand it like this. So basically, if we were having one two equal amount of electrode, this is one copper, this is other copper, and it is in the both are in the solution. So when electric current pass through it, this solution breaks down into Cu plus 2, SO4 minus 2, so Cu plus 2, Cu plus 2. So this Cu plus 2 gets deposited on it, this plate. As the electric current is passing through it, more and more copper, both, okay, the copper which is getting like broken down, it is coming from both the plates. Okay, so the left plate will also degrade, it will also degrade, it will break down, and the right plate will also degrade, it will break down. But what will happen eventually, that the all the copper which is breaking down will go and deposit on this side. Okay, so you are correct. Dhriti asked me na. So you are correct that both the electrode will break. The copper from both the electrode will break, but eventually all these are going to that electrode because it is negatively charged. So eventually all that is broken down will deposit in on it. Okay, so it will become bigger. Fine.
Okay.
And can you tell me why the copper plate on the positive terminal does not become like why does it lose its size?
Because the copper from that plate is transferred to the other plate.
Yes, correct. So basically, all of the copper is getting deposited on the negative plate, and nothing. If the copper breaks down from the positive plate, it does not get redeposited on it. It gets deposited on the negative plate. So that's why the positive plate will become deficient. Okay, it will lose its copper. It will keep losing, and it won't gain also. Whereas if the negative terminal is losing copper, it is gaining also, or because all of the copper is getting to it. So Bojo could get only one copper plate, so he performed. Bojo could get only one copper plate, so he performed activity 11.7. Which one is 11.7? This is 11.7. By connecting a carbon rod in place of the copper plate, which was connected to the negative terminal of the battery, he succeeded in obtaining a coating of copper on carbon rod. What is done here? Like I explained you, example of aluminium. Now what is done here? Connecting a carbon rod in place of the copper plate which is connected to the negative terminal. Now I am using a carbon. This is negative terminal. This is positive terminal. Positive terminal. Okay, this is copper. This is what this Bojo have done after performing the earlier activity. So what will happen? The solution is same. Solution is of copper sulfate CuSO4. Can someone tell me what will happen?
So copper will get deposited on the carbon rod.
Or the carbon rod. So
Yes.
okay. So this is what I have explained earlier also. That if you want a particular kind of material on which you want coating, like you want copper coating on carbon, so we will attach the carbon rod on negative terminal and the coating which is copper coating on the positive terminal. So all of this copper will deposited on the carbon, and we will get a copper coating on the carbon. Fine. Let's say you want a gold coating. You must have seen that there are some kind of utensil on which you see a shiny coating, but after some time when they are like they are rubbed or they come in contact with water or something, all that gold shining goes. Have you seen that the fake jewelry? We say fake jewelry. Have you heard about it?
Yes.
Yes, sir.
So how these fake jewelry are created? Can you guess?
Electroplating.
Electroplating. Very good. So what they will do? They will take a gold rod. Okay, they will take this gold rod. They will take the similar kind of solution, some gold solution, and they will perform the electroplating. Actually, the negative in negative terminal they use some iron rod. Can you guess why they are using iron rod?
Because it is a
Because
good
it's cheap.
conductor.
It's cheap.
Perfect. It is cheap and it is heavy. Okay, you know the value of gold. The value of gold is always measured in terms of weight. If if the weight of the utensil which is containing gold is heavy, that means you gonna be rich, very rich, because the weight is equivalent to the money it will get. So we use iron. Iron is cheap. Iron contain more weight.
Sir,
Now, yes, Rohit.
sir, may I leave because I have to study for science?
Sure.
Yes, sir.
Send me
I'm still
if you
recording.
have any
Yes, sir.
doubts.
I'm
Okay.
sending now. Thank you, sir. Bye, sir.
Bye. Okay, I will take 5 more minutes and then we can conclude. Okay, it's almost done. Okay, we will complete it. Fine. So I am explaining the fake jewelry kind of thing. So they take iron, they deposit this gold on this iron. So this gold which is depositing is not much. It is only small quantity. So it gets deposited on the surface. And as you guys know that gold is shiny. So when it is deposited on the surface, the iron rod will also become shiny. So it will appear as if it is a rod of gold or a utensil of gold. So this is how some people do fraud to do fraud using this gold plating. So they have done a gold plating and they say that this is a gold utensil and it is heavy. So they will charge very much money for it. Fine. And there are some utensil you use in your homes which are silver plated. Okay, there are silver utensils. So actually these utensil, what kind of like I don't know, or maybe I don't remember. Can you tell me, or you do you know what kind of material is there on the utensils we are using in our homes?
Can you repeat?
So the glasses, the tray or any utensil like the plate you are using. I'm not talking about the uh, clay plates. I'm talking about this silver coated plates. Do you know what kind of material is present on these?
Iron.
I think iron and
Al.
aluminium.
Yes.
Aluminium. I think there is aluminium in the utensils.
If it is made of silver, why is iron or aluminium coated on it?
No, it is not made on of silver. Okay, you can see that it is giving a shine of silver. So that means it is coated with silver. Okay, so silver is also very much expensive as that of gold. Okay, gold is expensive. Likewise, silver is also expensive. But the coating we have done on this utensil, it is very small quantity of silver. So we have done this coating of silver so that this material does not get spoiled with by the water or the carbon dioxide or the oxygen present in the air. Okay, so that's why we do silver coating. With the help of silver coating we can protect these utensils type of material present.
So is silver coating done on the handles of the cycle?
Yes, perfect, they are done on the handles of the cycle. So
But
if
silver is expensive, right?
silver is expensive, but the silver which is used in the coating is very small, very minute. Okay, so if you say you are having 1 kg silver, 1 kg silver, that means the whole material, the whole block, or you say a brick of silver you are containing of 1 kg, so that whole brick is containing the silver. But the silver amount of silver that is used for coating is very minute. Let's take 10 gram or 12 gram or 15 gram, very small. So the coating is only just on the surface, it gets deposited, it is not much. So it is not expensive when we do it on the utensil. Type of material present in okay, kitchen material: silicone, nylon, stainless steel. Okay, stainless steel, aluminum, copper. Okay, here are. So the common materials used in cookware and utensils are aluminum, copper, and iron. Okay, the glasses I don't know what kind of glasses you use. Like you must be using mm, the utensil, the glass material. Okay, I'm saying glass, so it is confusing. So the utensil you drink, we used to say it as glass, and it may be made of glass. Okay, no worries. So the cookware we and the utensils we use in our homes are of aluminum, copper, and iron, and they appear as silvery. Why? Because these aluminum, copper, and iron can be spoiled by the water. Okay, these may degrade when they are used in water, so we apply a silver coating on these materials so that they does not get spoiled. Fine. Any doubt until now? Say yes or no. Something doubt, and any doubt? Are you guys gone?
No, sir.
What about Manasvi and Manisha?
Sir, no doubt.
No.
No doubt.
No doubt, sir.
Fine. So in the vehicles also, this front part is coated to in this silver. Can you guess why it is important to have this front part?
Which part?
Why we need? Mhm.
For balancing.
Okay, someone said balancing. Others, can you guess why we are using? It is important to have this front part. Okay, let me tell you first that actually behind this front part there exists engine. Okay, behind this front part there exists engine, and in order to save that engine, this front part is used, which is of iron, and it is coated with silver. Can you guess why it is coated with silver? So that it does not get rusted. Okay, so this is the reason why we have this front part. This front part is used to save the engine, which is behind the this part, and this in this is contain of iron, because if you can guess that when it will hit any material or any object, this will be saved because it is of iron. Iron is tough, and to save this iron from getting rusted, we have coated it with silver so that it does not get rusted when coming in contact with moisture. Fine. So the process of depositing of layer of any desired material. So you can highlight this definition. The process of depositing of a layer of any desired metal on another material by means of electricity is called electroplating. So we are using electricity to do this process. It is one of the most common application of chemical effect of electric current. Fine. Electroplating is very useful process. It is widely used in industrial for coating metal objects with a thin layer of different metal. The layer of metal deposited has some desired property. So this is what I was talking about. So the silver has kind of desired property due to which it does not react with water, the moisture present in the air. Okay, so it have some desired property which the metal of the object lack. Okay, the iron lack that property, that's why we have deposited silver on it. For example, chromium plating is done on many objects. Chromium plating is done on many objects such as
Sir,
car parts. Yes.
sir, I need to leave, sir. I have another class.
Okay, then this is your homework, guys. I have explained everything related to electroplating, so you guys read until here. Okay, do this reading by yourself, and I will
Okay,
ask this
Okay.
from you in the next class. Fine.
okay, sir.
If anyone has any doubt, you can stay. Others can leave.
Bye, sir.
Bye bye.